All right, mathematicians, you've earned the right to call yourselves that because now we're not only just learning calculus, but you're applying it in our next unit. So we're going to look at how functions increase and decrease and how to tell if they're doing that using calculus. So let's jump in. A function's increasing if the y value is going uphill as you read from left to right. Right. So in this section, our function is increasing, the y value goes up, and after this local maximum, it starts going down, so now we're decreasing, right, as you read from left to right, and then it increases again. So you can say that the function has these intervals where it's increasing or decreasing. It increases up to this point, up to -1, so that's what this is. It's increasing when x is less than or equal to -1. And it also increases from here up. Right? So it also increases from x is greater than or equal to 2. You can leave the equal sign in. The point's a little ambiguous there. And in between, it goes downhill. So from here to here, from -1 to 2, the y values decrease as you read from left to right. And so there's the intervals which it's increasing and decreasing. Fine. We can see that visually, but you can also find that with calculus in this sort of way. If you were looking at a parabola, you know it's decreasing as you're reading left to right. If the points are going down, you can sort of read it off the graph. If you have a graph, that's easy, right? Another way to do it is look at the slope. And if the slope is negative, the slope of the tangent, that is, if the slope of the tangent's negative, then it's got to be going downhill, right? It's got to be decreasing. So that's what this means, right? It's decreasing if the slope of the tangent is negative. You could write that down. Slope of the tangent is negative. And then conversely, here our function is going uphill, right? The y values are increasing as we read left to right, but also the slope of all the tangents over there are positive, right? So at any point, if you look at the slope of the tangents, and you could take any tangent, could be there, all of them are going uphill, right? All of them have positive slope. So in here, the derivative of the function is positive. That means that the slope of the tangent is positive. That means it's increasing, right? So that's another way to look at it. So the slope of the tangent is positive. All right, let's look at that with some more technical know-how. Let's pull up some Desmos. Okay, so here's a parabola, and you can see as we move the point along, let me turn this off. This is just the point itself. So the point's going downhill, turns around, goes uphill. Okay, I've helpfully put in the tangent at this point, right? And you can see that the tangent is pointing downhill. The slope of that straight green line is negative, and it gets less and less negative until here at that vertex. It's horizontal, right? Zero slope. Not going up, not going down, zero. And then it turns around, and the slope becomes positive. You're going uphill, 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 still uphill, right? So you can tell that the parabola is increasing from here over because the slope of the tangent line is positive, and from here, slope of the tangent line is negative. If you plotted this, let's do 1.5. If you plotted the tangent line, would look like this. It's just a line, right? It's a horizontal line. If we put a dot on there, right now, the slope, the green line, is 0, and that's why this purple dot is at 0. As we go farther to the right, the slope becomes positive, so now we're in the positive part of the yellow line, right? So we have positive slope, goes uphill. Here we have 0 slope, and for our line, it's at 0, right? Now negative slope, and this is where this is decreasing on this side, that's why it's negative slope. And from here over, increasing, positive slope. Decreasing, negative slope, goes to 0. now increasing, positive slope, decreasing, negative slope, 0, increasing, positive slope. All right, let's look at that with something a little bit uglier. You can kind of see that as well. So I'm going to switch this out, change this to f of x. Sorry about the, change that to m of x, move him out of here, turn that off, turn that on. Cool. All right, uglier function. Let's turn this guy off too. Uglier function, but you can see that as our coordinate along the function changes, you can see the slope of the tangent line, right? Here we have, it's a positive slope, it's increasing. The function is increasing because the tangent slope is positive. Here, 0, local maxima. Here, decreasing after the local maxima, right? A local minima. Now we're at 0 again, so now it's no longer decreasing, and it turns around and starts increasing again. If we graphed this, right, if we graphed these two pieces, you'd see, well, let's turn this off, don't want to spoil the fun. If you right now looked at our purple dot, that represents the slope of the green line. So it's at 0 because the slope is 0. Here, purple's positive because our slope is positive, we're going uphill. But if you watch that purple dot, right, it keeps going up forever. It only bobs down to a certain minimum, right, and then keeps going up. And that's because here, our slope is positive. That's why the purple dot's in the positive sector, but it quickly goes to 0. Right here, our slope is 0, purple dot's at 0. And now we turn the corner and the purple dot goes negative because our slope of the green line's negative. Right? Can you see that happening? Now we're at like our maximum, the speediest you'd be going on skis is right here where it's the most inclined. That's why this bottoms out there, right? You can see it bottom out and come back right in that region. It never gets below that sector. And then we come back to 0, right? The green tangent line, the slope of it is 0 right now, and then we turn the corner and become positive again. You can see the purple dot go into the positive. If you graphed what the purple dot's doing between here and here, it would be doing this. It's following this parabola, right? And so the zeros of the parabola tell you where these apexes are, this maxima and minima. And so you can also tell from one side, on one side you have a positive slope, right, because we're going uphill. So it's still positive, 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 positive. At that apex, our slope is 0, we go to 0, and then now we turn around and now we have a decreasing function. We're going down, 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 until this 0 here. And now we no longer have negative slope. We have 0 slope, and now we go positive. All right. Hopefully that's not too much. But it's a way to visualize this piece that, let's turn off all these dots and stuff, that this red function, if you take the derivative of it, the zeros and the maxima and minima tell you interesting things about them. One of them, the things that they tell you is this, is where the slope goes from positive to negative. It tells you if the function's increasing or decreasing. So let's look at that with something like f of x equals x squared. Obviously, if you were looking at this, or maybe not obviously, sorry, if you were looking at this, it looks like it's increasing from here to here, and it's decreasing from here to here. Right? If you took the derivative of this, you should get 2x. Hopefully that's not too far out for you. The derivative is the tangent, the equation of the tangent line, right? So I want to know, I know this thing goes from going downhill to going uphill. Before it can change, it has to go to 0, right? So this has a negative slope here. Eventually it has 0 slope, and then it can go positive. So I know that on one side of this 0, wherever it's 0, I know on one side it's either going down or up, and on the opposite side it'll be flipped. So we could figure out the equation for the tangent line. When is the equation 0? And so you could plug in 0 for your y value. You'd say when is the slope 0? You divide by 2. The slope is 0 when x equals 0. So that's where we get this. And that kind of makes sense because it looks like it should bottom out right here at 0. Plug in a value if you like. And so plug in positive value, plug in 3 into here, and you'll get positive 6. So it should be positive on this side. You don't even have to check the other side. Well, maybe you should check the other side. Because then, so like let's try negative 3. Put in negative 3 and you should get negative on this side. Right, so that should be those pieces. You know that it switches at that 0. And therefore, if the tangent is negative over here, it's decreasing over here and it's increasing over here. So this is the way you can find it algebraically without having to graph it. Now, you don't necessarily need to do all that algebra while it's a simple function like x squared, but let's get a little more convoluted. Here's x cubed, right? I know that it's increasing from here to here, and it's also increasing from here to here, so it's increasing on the whole thing. And so we can figure this out if we don't have a visual of this by looking at the slope of the tangent, right? So the slope of the tangent here is positive. Here it goes to 0. Excuse me, I got to start smoking filtered cigarettes. Then it goes positive again. So it goes to 0 here, and we can, if you didn't see that there, you could put it in and say when is the y value 0? You divide by 3, and then you take the square root, and you'd still get x is 0, and that's where we get this piece from. All right, plug in a value. Plug in 4 or I don't know, 2. So you'd go 2 squared 4 times 3, and it's positive over here. Plug in a negative value like negative 2. You get negative 2 squared, positive 4 times 3, still positive. And that means on either side of the 0, the tangent line is going uphill. The tangent line is positive here and also positive here. So that means it's always continuously increasing function. All right, let's try one more, and we'll look at it graphically and then also algebraically. Get your head out of there, G. All right, so here's x cubed, blah, 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 all this mess. If you had the graph, it looks like it's increasing from here to here. That's real nice, and then increasing from here to here. We want to be able to do this without the graph and decreasing between them. And they've given us these nice points, but I want to be able to do that without having to like pull out the graphing calculator because that ruins any first date. So graphically, you could take the derivative of this. I know that I'm looking for the derivative because I want to see when the slope is going uphill. Look, it'll be going uphill on this side and going uphill over here, but it'll be going downhill here. Right? And if I didn't have the graph, you can do that with the derivative like this. You take the derivative of this piece, which is 3x squared minus 3, and the 4 has no derivative slope. If you graph this, and I don't want you to graph it, but if you did graph it, it would look like this. Ping. This is a parabola, and it has these zeros. Ping, ping. And this tells you when the tangents, these green lines, are 0. It tells you where this and this occur. Right? The zeros occur at -1, and the 0 also occurs at +1, here and here. I hope you don't have to graph this. You can solve this and ask for the zeros by just plugging in 0 algebraically and saying, hey, when does this derivative equal 0? You'd factor, divide by 3. Well, where'd all my math go? You divide by 3, do whatever kind of factoring tricks you want, add 1 to both sides, take the square root, plus or minus 1. Plus or minus 1, just like we thought here. Right? So those are the sites of the zeros. And so we can think about it this way. If we get rid of all this, if you wanted to use the sign diagram, you could say, I know that the function changes the slope from positive to negative at -1 and +1. So let's pick a value in between here. Let's pick 0 and see what happens. So you go 0 squared is 0, times 3 is still 0, and then -3. So this would give you -3 at 0. So this is negative between -1 and 1. Let's try something that's bigger than 1. So let's try 2. If you plugged in 2 here, you'd get 4, 12 minus 3 positive on this side. And if you tried something smaller than -1, you tried -2, you'd get the same sort of thing. You'd get -2 squared is positive 4, 12, positive 12 minus 3, positive over here. So we can tell that this positive means it's increasing from here to here, this positive means that it's increasing from here to here, and this negative means it's increasing or decreasing between the two. Alright, so that's how to do it visually. Here's a couple examples. If you like, find the intervals where the following functions are increasing or decreasing. Okay, fine. Let's take the tangent. Let's figure out the tangent, which is -3x squared plus 6x. Hopefully that's not too bad for you. And they factored it. Just to make it easier to see, when is the tangent 0, right? The tangent, if two things multiplied together give you 0, either this is 0, so either x equals 0 or x equals 2. So those are the two sites of our zeros. And so if we were drawing a sign diagram for the tangent, you'd say, hey, 0, here's 2, let's try a number like 1, plug it in here, and see what you get. And when you run through that sign diagram, you figure out that it's positive between those two and negative on either side. And so just using some algebra, you can see that it's decreasing from 0 down and from 2 up, and that's what this part's about, and it's increasing between those two, and that's what that part's about. Here's the original, and you can see that that's true, right? From here, it's going down, 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 down until it gets to 0, and from this maximum, which is at 2, it's going down, 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 and between them, it's going up. We don't need to graph it, we just use a little calculus, and then we use a little algebra. Neat. Let's try it one more time, and we'll go from there. So I'm trying to figure out when this is increasing or decreasing, and so let's look at the derivative. If you take the derivative of this thing, it looks like that. You get the 12 for multiplying the 3 and the 4, and then decrease the exponent, same thing here, and the 2 has a 0 change. This they factored, or you can factor. That's one way to find the zeros. We want to find where this has no change, and so that's the site where, you know, the signs change on the derivative, which means it goes from positive to negative or negative to positive. This occurs when if two things are multiplied, when this is 0, and that occurs if you put in 0 for x, or when this is 0, and that occurs when x is 2. So you got a sign diagram. It's probably hiding under here. There's your sign diagram. Oh, we don't know that. We just know this. Selective. And so you can choose a point in the middle, maybe 1, and put 1 in there and see what happens. See if it's positive or negative. So let's put 1 in here. So this is 12, and 1 minus 2, -1. So this should be negative here. And then you should get some switching between there. It doesn't always happen, so it's good to check, because in this case you had a negative on the other side too. So you should try -1 and see what happens. -1 squared gives you 1, and then 12 times that gives you 12, and then this is -1 minus 3 gives you, or minus 2 gives you -3, gives you a negative over here as well. So you do have to check if you're not sure about the function. This one's a cubic, so you know it's going to be a little squirrely compared to if it was a quadratic. You know it would be fairly straightforward. This is a cubic, so I'd check both of them. And then check on the other side, check 3. So you'd get 3 squared. This would be a positive number, and this would be 3. This would be positive, so positive times positive gives you a positive, right? Okay, so you know that if it's positive, it means that there's an uphill slope. It's going up, so it's increasing from here up, from 2 up. It's increasing, so that's this piece, and it's decreasing here. All right, so from 2 down. This point where it kind of stops, they call a stationary point, and we'll get to that next time. This is if you're interested what the graph looks like, and you can tell this is still decreasing from here to here. This point 0, sorry, right there is the stationary point. It just pauses from going downhill. It's like, pause, and then keeps going down. And we'll look at stationary points. Next time, and this is the point where it stops and goes uphill. Cool? Good luck with yourself.